Hi, my name is Eva Maria Molin and I'm from the AIT Austrian Institute of Technology from the Center of Health and Bioresources. And today I'm presenting my work towards breeding of stress-tolerant winter wheat utilizing genomics and phenomics that is integrated with machine learning and explainable AI. So let's start with a bit of a background. It is fact that there is an ongoing rise in temperature as well as a change in precipitation, not only in Europe but actually worldwide. And this is leading to increased abiotic and biotic stresses. And as you can see here on the picture, the classically rolled leaves of drought stress winter wheat in Austria. And this is ultimately leading to yield loss, which is then affecting food security. And there is definitely the need to support the breeding of more stress-tolerant crops. And therefore, we started with the Wheat-Wiz project, in which we aim to accelerate the breeding of more stress-tolerant wheat genotypes with technologies such as UAV-based phenotyping, associating those phenotypes to the genotypes for supporting the breeding with tools such as marker-assisted selection. And all these steps involve machine learning and/or explainable AI to a certain extent. Our ultimate goal here is to find parameters that are on the one hand fast to measure, that can detect the trait of interest very accurately, and of course that finally have the potential to be used by the breeder within breeding programs. And today I am going to focus on the first part here on the UAV-based phenotyping. So the trait of interest for us was the yellow leaf rust, which is a well-known pest in wheat. And for its phenotyping within the project, we used an UAV equipped with multispectral camera and thermal infrared. We performed standardized flights from a quite high altitude, actually of 60 meters. For this, we were using fixed ground control points to get a high accuracy. And we used as ground truth data agricultural standards of yellow leaf rust scoring scaling from 1 to 9. And this all we did for over 250 genotypes in the year 2023. And one of the main tasks within this step of UAV-based phenotyping was to create a deep learning architecture in order to fulfill the main aim of optimizing the bands for the possibility to use cheaper cameras and drone systems that at the end can be easily used by the breeder. And well, for this we designed the TriNet architecture. This architecture consists actually of 3 steps. The first one is the spectral processing step, that is for the identification of the most pertinent spectral bands and vegetation indices. The second process is the spatial process, that is here for the extraction of patterns from the image data, and at the end the 2 dimensions, the width and height, are collapsed, and this data is then fed into the third step, the time processing, which actually captures and exploits temporal dependencies, as we did of course data acquisition at several time points. And by analyzing all these data, it turned out that each of the processes involved a handful of most important spectral components. Such on the left hand you see, after the first attention, had the AVI popping up as one of the most important ones. Also, the red band in the middle figure turns out to be the most important ones, and when you look at the attention head number 3, you can see the GNDVI index appearing as most important one. And a deep dive into the data actually revealed that the RGB only variant performs quite competitively, and this means that at the end a cheap RGB camera on a decent drone would basically do the job of yellow rust phenotyping. So to come to the conclusion here, in our study for yellow rust phenotyping, we used the higher granularity of the yellow leaf rust scoring from 1 to 9, and by using a lower spatial resolution, we actually could yield a reduction of basically data and computing resources. And we also incorporated explainability components with the implementation of the attention heads into our deep learning architecture. And finally, I would like to thank you for listening, and if you have further questions, don't hesitate to reach out. Thank you very much.